Hello and welcome to a demonstration of DXC Technologies' Industrial Internet of Things capabilities. Our platform, OmniLocation, is a geospatial and geomatic product suite that allows us to live within any IoT technology platform such as Lumada. And we'll be demonstrating our capabilities of making sense of geospatial data in real time in an industrial facility, whether remote or centrally located. We're looking at a surface mine in Northwestern Australia, and so we'll zoom down into that. And as we take a look at this facility, the assets will become immediately available to us, not only for their location, but for their status. We can understand clearly through the symbology exactly what the current status is of any particular asset in its operation, so that we have an understanding of whether it's in service or faulted, whether it's in standby mode or currently running, whether it has scheduled maintenance that's coming up. In addition, with the simple interface, we're able to look at a table of all the assets, search them according to asset types, smart or dumb, categories, and even site IDs, which mines they're located at. But with a single glance, we're able to gather a lot of information if we're talking about just managing the facility. So I'm going to go down a little bit further into the facility itself. And as the screen repaints, what you'll note here is that we have a very high degree of fidelity, and that comes because the client provides photographic imagery that's updated every 2 weeks, and that's their particular schedule, that can easily be uploaded into OmniLocation to get a very high clarity view of all of the on-the-ground assets and infrastructure. If I click on any particular asset, it's going to give me an immediate update on how much fuel is in the tank, how it's running at present, how long it's been running, battery status, and so on. And so for the person who's managing operations, this is a key set of information. But there's many different groups that make use of this technology on site. So let's go another layer deeper. We'll click on the link there that says details. In this case, we're looking at a lighting tower. And as we look at those details, what we'll note is that there's more links within the system. In addition, we have a listing of all of the faults that have happened with this particular asset. The client has set it to 6-month increments, so there's nothing on this particular asset. It's a bit new. But we can set the program schedule as well for when it will be automated to run and turn itself off in order to conserve fuel, because these clients have noted that if these lighting towers, which are constantly moved around to support operations, if they run out of fuel, especially at night, it's going to cost somewhere between $250,000 and $300,000 to replace the fuel because of the lost time on tools. So as we look at the interface, then we have the ability to put it in remote control so that we can turn off a machine that was left on in the daytime. We can start a machine remotely, given the danger of this particular site and the almost continuous blasting that's going on. Not having to drive to the asset to engage it is a feature that is quite popular with the client. But let's go a little bit deeper into detail. So if my responsibilities include maintenance on this particular machine, then I'm going to want to see it in much tighter increments. So what I'm going to do is change the date on this to reflect the last time that we saw this particular machine. In 2014, before it went live, and we'll do the same thing for the end state, and that will allow us then to see exactly how the machine is running at a particular set of coordinates and time specifications. So as I refresh the table, we see 15-minute increments of performance on that particular date. We can understand how that developed by keeping, at this point, 6 months of data, which is what the client required. And the technician themselves can even put this into 10-second mode, so they can make incremental repairs and see the immediate effect on the particular systems they're monitoring. And all this is done through a CAN bus interface inside the lighting tower that is carried through the IoT transaction communication to give the users two-way conversations with the machines in near real time. Again, 10-second delay at best, and then periodic or called updates at the least granular. And that demonstrates the basic capabilities. We include alarm events that can be set by the client based upon particular values in the CAN bus. In addition, we're able then to create reports from those for a particular set of time, and we're able to set geofences that allow us to understand particular areas of the facility and how long assets spend inside those geofences, or when they enter or when they leave, depending upon how that is set up. You'll see at present we've set up 70 different alarm conditions, all based from the CAN bus, but the client is able to add to those and determine who will be getting emails from the system when particular alarm conditions exist. In addition, we include administrative interface that allows us to make clear the types of alarms that we're generating, the asset maintenance specifications. That is, when new tags, new assets are brought into the facility, the categories of maintenance, as well as different types of tags that are available through the system. And so everything from painting geofences with a handful of clicks to being able to associate and disassociate different devices to particular tagging systems as technology changes over time, because we all know that that's going to happen. This concludes my demonstration of our technology and the concrete example taking place in Northwestern Australia. Thank you.